Carnegie scientists explore the outermost reaches of space, the mysterious depths of the Earth, and the origins and mechanisms of life. Our scientists are chosen for unique skills and boldness. Their amazing discoveries, spanning more than a century, demonstrate the power of freedom. Carnegie investigators are intrepid adventurers who pursue their goals even as they mentor and train the next generation of scientists. They are free to question, to wonder, to creatively pursue ideas from the vast universe to the subatomic world. We explore the past to understand the present and inform the future.
The seawater is becoming more acidic. Its oxygen reserve is diminishing. This trend is definitely worrying. Yet, many scientists remain cautiously optimistic that we still have time to save our seas. Prominent among them is our guest tonight, Dr. Jen Lubchenco, University Distinguished Professor and Marine Science Advisor to the President at Oregon State University. Dr. Lubchenco is an expert in biodiversity, rocky seashore ecology, climate change, and ocean sustainability. Her publications in these areas are among the world's most highly cited. She's also a fierce, committed advocate for the health of the oceans she studies. Dr. Lubchenco has taught at Oregon State since 1977, after earning her PhD in ecology from Harvard and spending a few years there as an assistant professor. She also serves in many government administrative positions in her career. Between 1996 and 2006, she served on the National Science Board appointed by President Clinton. In 2009, she was appointed by President Obama to be Undersecretary of Commerce for Oceans and Atmosphere at NOAA, a position she held on leave from Oregon State until 2013. Then from 2014 to 2016, she was the first U.S. State Department Science Envoy for the ocean. She's a member of the National Academy of Sciences, the American Philosophical Society, and the Royal Society. She has served as president of several scientific organizations, including the American Association for the Advancement of Science and the International Council for Science. She has founded several private nonprofit groups that enhances scientific communication and public engagement. Her awards include a MacArthur Award, which is also known as the Genius Award, a Heinz Award for the Environment, a Peter Benkley Ocean Award for Excellence in Policy, a Blue Planet Prize, and the most prestigious award given by the National Academy of Sciences, the Public Welfare Medal. With her deep experience in the worlds of science, government, and public engagement, Dr. Lubchenco is an ocean steward of the highest degree. We are very honored to have her among us tonight. Ladies and gentlemen, please join me to extend a warm welcome to the Honorable Dr. Jen Lubchenco.
Thank you, Ishen, and good evening, everyone. It's my pleasure to be here with you this evening. Science is what brings us together here. And to me, science is fun. It's also about wonder and awe and magic, mystery and beauty. Science is also often very useful to us in helping us understand how the world works, how it's changing, and helping us understand how we can use the planet without using it up. My remarks tonight are going to focus squarely on various things that are happening in the ocean. And if you've been paying attention to the news or listening to Ishen's litany of challenges in the ocean, you might think that my title is a bit of a disconnect. There are, in fact, very real serious problems in the ocean, from coral bleaching to overfishing, ocean acidification, lots and lots. There seems to be an endless litany. You see images of massive amounts of plastic floating in the ocean. And all of that is indeed the case. There are major challenges. But I bring tonight a message of hope, because there actually are some amazing things that are happening around the world that at least give me hope, and I'd like to share some of those with you here tonight. The bottom line of my remarks are going to be to focus on the question, can we use the ocean without using it up? I'm going to share some new scientific insights, some new tools, some partnerships that are turning some of these disasters into opportunities. And I'm going to focus on the connection between the ocean and people, why we really need healthy, productive, and resilient oceans. I'm going to say what some of the big challenges are and what some of the solutions are that people are actually implementing on the water right now. And then focus attention on what have we learned from looking across those different solutions? What are some of the lessons learned so that we can accelerate the pace of implementing those solutions and bring them to the scale that we needed? And then I'll touch on the role that each of you can play if you want to be part of the solution, not part of the problem. I'm going to begin with giving you a sense of where I'm coming from in this focus, and then talk a little bit about why you should care, what some of the problems are, what are the solutions, and then what can you do. So my perspectives, as Ishen mentioned, I'm a marine ecologist. I've spent about 40 years in the academic world doing research many places around the world, and really falling in love with the incredible variety and majesty of life in the ocean. I've also spent a fair amount of time bringing science to the attention of policymakers, spending 4 years here in Washington, D.C. As part of President Obama's science team and as the administrator of NOAA. A wonderful, fantastic scientific agency that does science, funds science, and uses that science to deliver services as well as be a good steward of resources. I had lots of opportunities during that time to do a lot of different things. As a marine scientist who's worked on climate a lot, it was also interesting to learn about meteorology and building satellites and the variety of other things that NOAA does. I spent a lot of time not only with the people in NOAA and many of the people that we serve around the country, but also with other members of the administration, the cabinet, a number of governors, and at the same time with members of Congress. And here I am in the bottom photo giving one of the first and perhaps very, very few chemistry lab demonstrations for members of Congress. In this case, focused on ocean acidification to explain to them what ocean acidification is, how it works, what some of the general principles of it are. I also connected with people around the world on oceans, climate, weather, coastal issues. That is part of what NOAA does. Interacting with global leaders from many different walks of life. And I learned a lot about what folks do and don't know about the science of, let's focus on the ocean for a moment, or how they think about science. For example, NOAA, when I was there, was in the process of building the next generation of weather satellites. And I learned that over 90% of the data that go into our models for weather forecasting come from satellites. So they play an absolutely crucial role in helping us be able to predict the weather as well as forecast if there are going to be some severe events, hurricanes, tornadoes, whatever. We were building that program I was up on the Hill talking to members of Congress about how important this program was to fund. The satellites that were up there now are working well, giving us good information, but we need to be building the next generation of weather satellites. And this one key member of a congressional committee said to me, "Doctor, I don't need your weather satellites. I have the Weather Channel." And I thought, okay, I need to explain that the Weather Channel and AccuWeather and all the other private weather providers get their information from NOAA, and most of that for these weather forecasts comes from the satellites. So there is a lot that people, that scientists take for granted that other people know about science, and sometimes we forget to explain the intermediate steps and connect the dots for people. Another quick vignette that I'll give you was with Vice President Biden, whom you see here swearing me in. And about a year after I was sworn in, we were challenged with the Deepwater Horizon BP oil spill disaster in the Gulf of Mexico. And the president asked the vice president to travel to the Gulf and meet with fishermen and tell them what the federal government was doing, what we knew, and to listen to them, understand their concerns. Vice President Biden said, "I'm happy to do that, but I need someone who is deeply familiar with what we're doing, who understands the impacts of oil on the ocean environment, on fisheries, and can help bring me up to speed on these issues." So I flew with the vice president in Air Force Two to the Gulf, and on the plane was briefing him about those very things. How does oil impact fish? How does it impact crabs and shrimp differently from fish? How does it impact oysters differently from those? What the federal government was doing to close areas to fishing so that we didn't have any chance of having contaminated seafood be eaten by people, etc. And partway through this description, he stopped me and he said, "Hey, wait a minute, I thought you were a scientist." And I thought, what did I say? And he said, "But I just understood everything you told me." How many times has Vice President Biden been briefed by scientists? Hundreds, if not thousands of times, and he still thinks he can't understand us. So that's a lesson to our scientists that we need to do what I call become bilingual, be able to speak the language of science, but also speak the language of lay people. I also had the fortunate opportunity to spend 2 years as the U.S. Science Envoy for the ocean, traveling to do science diplomacy to many developing countries around the world. And I did so in a way that focused on bringing new science to the table to help countries think about, but also learn from them, what they were learning about how we can use the ocean to provide food security, poverty alleviation, job security, things that they were all interested in doing. And one thing that I've learned is that many people look to the ocean for a variety of different things. Many people understand that the ocean is important to them and they get different things from the ocean. But the ocean does a lot more for us than most people begin to appreciate. Some people depend directly on the ocean for their livelihoods. Other people see it as a place to play, explore, relax, recharge, be inspired, spend time with family and friends. The ocean provides wonderful, healthy seafood, but it also provides cultural identity for many people. But in addition to those things, the ocean provides a wealth of benefits that are hidden to most people. The ocean provides over half of the oxygen that we breathe. Every other breath you take was generated by microscopic plants in the ocean. The ocean absorbs over 90% of the excess heat that is trapped by greenhouse gases, so it plays a really key role in moderating our climate. And the ocean absorbs about 40% of the carbon dioxide that we emit, also playing a key role in helping to slow down the pace of climate change. The downside of this absorption of CO2 is that it's making the ocean more acidic, so it comes at a price. All of these things are important. We can't see a lot of those, but they are important nonetheless. From the surface, we can glimpse some of the beauty and the bounty of this amazing diversity of life that's in the ocean. And for millennia, the ocean for people has been a grocery store, a playground, a highway, a pharmacy, a church, a library, a school. It has served a variety of needs for people. But those people who make their living from the ocean, fishermen, for example, or those people who study the ocean, marine scientists, more and more are seeing serious problems in the ocean. And you see some of that reflected in the news accounts that we have already mentioned. So what do we know about what's happening in the ocean? I'll give you a quick vignette in 4 slides and 33 words. Here's what we know. A century ago, the ocean had some local pollution, but was mostly free from nutrient, chemical, and plastic pollution, and was immensely bountiful, teeming with huge fish, and a diverse array of top predators who kept things in balance. Most of the ocean was a de facto no-take marine protected area because most of it was too remote, too far away, too deep, too inaccessible. Fast forward to now. Today, the oceans, in just a few decades, have been depleted, especially of those big fish and top predators, become polluted, disrupted, heated, more acidic, and less resilient. Those changes matter to life in the ocean, but they matter to you, to each of you, and to everyone on this planet. Breaking down some of those problems, just to sort of lay out a litany here. Overfishing, illegal fishing, loss of these safe havens for wildlife and protection for ecosystems, climate change and ocean acidification, pollution, but mostly lack of awareness and lack of political will and public will to do something. So the grand challenge that I think faces us is, can we use the ocean without using it up? Can we do so equitably? Is it hopeless? The things that we have set in motion have taken on a life of their own. There are more and more people out there that need to be fed. There are more and more waste that's being generated. Is this really possible to turn around? And I would say to you that no, it's not hopeless, but it is very, very difficult and will require a different way of thinking about the problems and the solutions. There's very encouraging progress that's underway. Scientists are working with businesses, with communities, with leaders to propose solutions, not just identify problems. Environmental scientists have this reputation of just telling us that bad stuff is happening and never offering solutions. That's changed in spades. Citizens are becoming more engaged, especially a lot of people in coastal communities for sure, but also inland. Policymakers around the world at local, state, national, global levels are taking action. Not enough of them, not enough of them, but there is momentum that is growing. And they are collaborating and using some really cool new technologies. So on the ocean front, I would assert to you that, in fact, good news is bubbling up a lot of different places. There are a lot of things that are happening that we can replicate and scale up, should we choose to do so. I'm going to focus on some of the new science, the new partnerships, and new leadership that are driving some of these very positive solutions that I see emerging, and focus you on 3 examples: fisheries, illegal fishing, and marine reserves, which is a type of marine protected area that is completely protected from any extractive activities. So I'll do this in a problem and then solution format. The first one, overfishing. The solution is fishery reform. Not an easy thing to do, but important. Over 3 billion people depend on seafood for a significant fraction of their protein. And that's growing. And with the growing number of mouths to feed, this is going to become increasingly important. When you hear the term food security, don't just think about grain and livestock. Think about food from the sea, because it's an important part of diets today, and it will be even more important in the future. We don't have a very good track record of managing fisheries sustainably. These are data from the UN Food and Agricultural Organization that countries report, and it gives us a snapshot of how very drastically things have changed in a very short period of time, starting in 1950 on the left and going to 2010 on the right. And you can see the light blue is developing fisheries, which used to be over 80% of the fisheries were underexploited. They were just developing. Fast forward to today, that's less than 10%. We currently have about 30 to 40% of fisheries are overfished, and 50% are fished at their limits. So that gives us a real sobering look at the extent to which we have very rapidly, in a number of decades, completely begun to drain the ocean of seafood. And if we want to have healthy seafood in the future, we're going to have to be smarter about how we manage fisheries. Fishermen around the world today, especially in developing countries, are fishing harder and harder for fewer and fewer returns. Fortunately, this is beginning to change. People have said, this isn't sustainable. What are our options? And scientific information has given us some new answers. There was an analysis that was published in 2008 by ecologists and economists that said, we've done an analysis of 11,000 fisheries globally, and we have discovered that the way fisheries are managed makes all the difference in the world. That if fisheries are totally open access, they are likely, and it's a race to fish, all the fishermen in a fishery are competing against one another, it almost always leads to overfishing and collapse. If, on the other hand, fisheries are managed with a relatively new type of fishery management called rights-based approaches to management, fishermen are incentivized to be good stewards of the resource. This new type of fishery management flips the incentives for them, and so they are incentivized not just to fish hard now to catch as much as they can, but to have sustainable fisheries. And that actually makes all the difference in the world. The solution here that is emerging is to fish smarter, not harder, using new types of fishery management that enable fishermen to do what they know is important, to be good stewards, but it gives them economic incentives to do exactly that. This type of fishery management is widely used in the United States now. In 2006, there was a major new law that was passed by Congress that gave strong marching orders to NOAA that regulates federal fisheries in federal waters. And it said, enough of this good lip service to ending overfishing. You must end overfishing. There's a mandate to do so. The quotas have to be based only on the science. There's accountability in the system. It has an ecosystem focus. And for fisheries for which it's appropriate, the fishery management councils that propose the management plans may choose to use these rights-based approaches. The combination of those two things has been nothing short of transformative. This is a really good news story that most people in the US have not heard of, and I'll give you some data. Let's compare what was going on in the year 2000 versus the latest year for which data are available, 2016. In the year 2000, there were 92 stocks that were overfished. Because of these new reforms, that had been slashed to 38 by the year 2016. That's really impressive progress. Even more impressive, though, is the fact that many of those stocks that had been completely decimated, had to be closed, have now been rebuilt so that they can again be fished sustainably. And in the year 2000, there were 0 of those. By the year 2016, there were 43. So we've seen an amazing turnaround in recovering depleted species. And so there's a lot more food and a lot more fish in the sea because those fish are important in ocean ecosystems as well as to be eaten as seafood. Those two things are going hand in hand. Recovering fisheries, fishing smarter, not harder. And in the more recent years, we've seen this translate, more fish in the water, translate to 23% increases in catches, 32% increase in value, and a 35% increase in jobs. And so this is a real good news story. It's not every single fishery in the US. There are still some that we have work to do on. But it really provides hope that it is possible to end overfishing. It is possible to recover those species and to have more fish in the sea. I can't give enough credit to the fishermen all around the US that drove these changes, that stepped up and proposed solutions, working with scientists, working with managers, leading their communities to really try a different way of fishery management and make things work. We had the opportunity to recognize some of these gentlemen as champions of change for sustainable seafood at a White House event. And these 3 guys, all of whom I've worked with, I have just the most admiration for. So we're seeing scientists and politicians, NGOs and fishermen working together to create management reforms. And this kind of change is happening not only in developed countries like the US, but in some developing countries as well. And Belize has really been a pioneer in this arena. They've had real serious problems with fishing. They adopted some of these rights-based approaches that were community-based, fishermen-driven, and they implemented a pilot project in 2011 that was so successful it's been adopted for the entire country now. In fact, there are a large number of rights-based fisheries around the world, more than 200 fisheries worldwide in 40 countries. So this is a very powerful tool that is not yet having the impact that it could. It's not a panacea. It's not appropriate for every fishery. But where it is used appropriately, it can really be transformative. The scientists that did that initial analysis have continued to look at what is the potential for recovering species, how much more could we get from the sea. And they've provided this analysis, which shows you the percentage of healthy stocks as a function of time starting in 1980. And the green line shows you the decline that we have been on up until the present. The dark blue, almost black line, shows you the future trajectory if we don't change anything today. The alternative is the light blue teal line, which shows you if we could fix all fisheries and have them be sustainable, there is the potential for having a much better future, much more fish in the ocean. And that translates to impressive triple bottom line wins with more seafood, more profits, and more fish biomass in the water. Now, as you might imagine, this has gotten the attention of a number of governments, especially in developing countries that do a lot of fishing. And when I was Science Envoy for the Ocean, I helped create a new exchange program between Chinese and US scientists that is taking a very close look at the kind of results that I just showed you and looking to see what lessons might be learned from both countries in helping to make fisheries more sustainable globally, as well as within those two nations. Indonesia is another big fishing nation that is really struggling with how do we end overfishing, and they have been partnering with a number of scientists to do exactly that, to figure out how their fishery management can be flipped. So there is keen interest on the part of a number of countries in doing this. And I think that we're going to see some bumps along the road, but some very significant changes in the not too distant future. So to wrap up the first piece on overfishing, we've seen that it is possible to use good science, to work with industry, with communities, with managers in a variety of different types of circumstances to end overfishing, recover, rebuild fisheries, and make them more sustainable. And that's a win for the environment. It's a win for people whose livelihoods depend on the ocean. It's a win for seafood lovers. Turning now to a second problem, which is highly related, illegal fishing. This is a very big problem, and there's some really cool new solutions that have emerged to address it. IUU is the jargon term that's used to describe illegal, unregulated, and unreported fishing, and it is big business. It is as much as $24 billion a year that it represents that is illegally caught and sold globally. This problem has been so challenging because the ocean is so immense, and you can't patrol every place. You can't be out there all the time and catch all the bad guys. It's what I call the wild, wild wet out there. Fortunately, there have been a number of new developments that are changing this dynamic. Those include new policies and new political will to tackle this problem and do something about it. Interpol now has an international fishery crime unit. Secretary John Kerry began a series of global conferences to elevate oceans on the international diplomacy scene, inviting other foreign ministers and heads of state to come and make announcements about things that they were doing to recover the health of the ocean. This Our Ocean Conference has really become the place for governments and others to talk about some of these good things that are happening. During the time I was at NOAA, we also negotiated an international agreement that is called the Port State Measures Agreement. Very sexy term. It's actually an agreement to end illegal fishing, and it says that all the countries who sign it will work together to not and focus on the fact that all those illegal fishing vessels out there, they have to come back to port to sell their fish. So you catch them in the port. And it's an agreement by those countries to do exactly that. It was adopted in 2009, entered into force in 2016. 50 countries plus the EU have now signed it, and they are working actively together to catch some of those bad guys. Against that backdrop of political will has been, and new policies, has been a real incredible development that uses technology and artificial intelligence, machine learning, to take advantage of the fact that ships have on board an anti-collision device, and that device tells someone where they are all the time so that ships aren't bumping into each other in the middle of the night or in a storm or in the dark. Those signals can be detected from satellites, and if you have the right kind of software, you can tell exactly where all the fishing boats are in the world at any moment in time, and you can tell who's fishing by the kind of tracks that they are making. So you can follow them through time and see what they're doing and see where they are. A new program called Global Fishing Watch, which is a partnership between SkyTruth, Google, and Oceana, has developed this new software. And each one of those pinpricks that you see on this map is a fishing vessel. And I'm going to show you, and those are all the fishing vessels at a particular time. Now focus, if you will, on this area of the Pacific. And you see these spots there where there aren't any fishing vessels? We're going to hone in on those in the next image. And this red area here, that has lots and lots of fishing vessels right now is part of the nation of Kiribasa's fully protected marine area called Phoenix Island Protected Area, or PIPA. PIPA used to be fished, and then the country decided they were going to turn it into a fully protected marine area. And the animation that I'm going to show you will show you when the vessels were there, and then as the PIPA began to be implemented, you can see all the fishing vessels clearing out, so that by the end of the time, there are very few there, but there are some. And the point is, you can see them, and you can go out and get them, and you can tell what each of those points is. You know what the vessel identification number is, you can follow where it goes. And so this is a very powerful new tool to catch those bad actors. And knowing that that is happening is empowering more governments to create protected areas, but also to really focus on catching the bad actors. All of this, both with the fishery reform as well as clamping down on illegal fishing, has really gotten the attention of the big seafood companies. And the 10 largest seafood companies in the world, both fisheries and aquaculture, have joined forces to create a new organization called SeaBOS, Seafood Business for Ocean Stewardship, that has been created by and brokered through the Stockholm Resilience Center. And these companies have realized that they have been part of the problem. And through talking to scientists and one another, they have come to an agreement and announced publicly that they want to be leading in the solution. They don't want to be the problem anymore. They're very concerned about climate change. They're concerned about public attention to slave and illegal fishing. And they are making public commitments to change some of these practices and policies. It's still too early to know how successful that will be, but it's very, very encouraging. Shifting now to the third problem that I want to bring to your attention is loss of safe havens and ecosystem protection. Strongly protected marine areas is the solution. And this is to remind you that the countries of the world that are coastal have an exclusive economic zone that goes out to 200 nautical miles. And excuse me. If you add up all of those EEZs around the world, that's 42% of the ocean, the surface area of the ocean. And then there's the single high seas common that is 58%. So the EEZs are the place where most protected areas have happened. The first protected area that we know of was created and registered as created in 1888. And since that time, there have been lots of them around the world, but they've been, for the most part, very, very tiny and not really occupied much space. This figure shows you, starting with this one in 1888, that the total cumulative area in these protected areas has been minuscule up until about the year 2000. This is 0.5% of the ocean, so this is about 0.3 right here. So the fact that we've had thousands of them, and the fact that conservation scientists know how important these are, many call them blue parks of the ocean, there hasn't been much progress in creating them. New scientific information has been one of the things that has totally transformed this area. That new scientific information has provided new guidance about what works, what doesn't work, where they should be, how they should be managed. And what we have learned is that these protected areas actually do an amazing job of protecting biodiversity. If you stop fishing in an area, things get bigger, they get more abundant, they get more diverse. Excuse me a minute. Much of that bounty spills out from the protected area into adjacent areas. But one of the most important things that protected areas do is allow fish or invertebrates to get really, really big because they're not being caught. And those big individuals make huge number of young. So on this slide, I skipped one, sorry. So this particular fish, a vermilion rockfish on the upper left here, is about 15 inches. And it makes 150,000 young. Each of these little icons is 100,000 young. So this size fish makes 150,000 young. But if you let it grow to almost 24 inches, it can make 1.7 million young. Thank you for bearing with me. So allowing those fish to get a little bit bigger makes a huge difference in terms of the future sizes of those populations. Now you're going to hear a bunch of clicking. In addition to that, these fully protected areas, when they are releasing their young, they are transported in ocean currents and often go huge distances away from the protected area. And that can serve to, I'm just going to take 1 minute here. I'll let this cough drop work its magic. I apologize. So these protected areas can bring immense benefit, recover areas inside, but they can also help recharge adjacent areas outside, especially if there are depleted fisheries. We also know that they play a critical role in restoring the ecological balance within a protected area, recovering those top predators and letting them play the key role that they do in regulating the abundance of other things in the community. And they are an important buffer against mismanagement, management mistakes or uncertainty, and they provide reference areas. More recently, we've begun to appreciate how incredibly important these areas are also in enhancing the resilience of the area inside the protected area, resilience to environmental changes such as climate change. And in fact, people are now talking about marine reserves as climate reserves. The fact that we now have new tools like Global Fishing Watch is making it even more feasible for countries to create these protected areas. So we have new science and new tools, and that combination and having a conference like the Our Ocean Conference, where countries can make announcements and get praised for making announcements, there has been a huge uptick in the number and area of protected areas globally. So you see the slide that I showed before that ended in 2000, we've seen just a huge increase, so that now we have implemented marine protected areas almost to 3.6% today, when it was 0.3% a decade ago. So over an order magnitude of increase. This is nowhere near as much as is needed. Scientists say that we probably need on the order of 30%. Countries have committed to 10% by 2020. But in fact, the fact that there is good science, there is new management tools, has really emboldened countries to tackle this problem. Currently, we have this 3.6% implemented, and this is all kinds of protected areas. The implemented ones that are just strongly protected or fully protected are 2%, so that's very significant, that's good. We have another that have been legally designated but not implemented, and then others that are proposed. So in fact, there's increasing momentum in this arena. Between 2015 and 2017, there were a very large number of very big protected areas that were announced by a number of countries. Palau beats everybody, protecting 83% of their country's ocean. In a few years, that will go into effect. But New Zealand, Chile, Seychelles, UK, Mexico, and US have all really stepped up to the plate and done some pretty amazing job in terms of realizing that if we want healthy, productive, resilient oceans, we need to protect some of them from extractive uses. Seychelles is a country that has done some very creative things, aided by the Nature Conservancy. Seychelles had a lot of foreign debt, and they, TNC talked to them and the people who held the debt and did a deal that's called a debt for nature swap to relieve their debt in exchange for creating a management plan for their whole EEZ and setting aside 30% of that in protected areas, but also creating a climate adaptation fund to use to do climate adaptation. So some real creative new ideas are coming to the fore here. During President Obama's time, President Bush had done the first very significant creation of protected areas in the ocean using the Antiquities Act to create marine national monuments. Obama followed that. When he came into office, 5% of the US EEZ was strongly protected. That 5% had been created by President Bush. And when President Obama left office, that was up to 23%, is now strongly protected. So this is yet another area in which we have made some very significant headway. And in fact, these marine monuments, like the monuments on land, are under review by the current administration. And we hope that they will continue to be doing the magnificent work that they are currently. Countries have committed to protecting 10% of the ocean by 2020. Both through the Sustainable Development Goals as well as through the Convention on Biological Diversity. Most of those, again, are in countries' waters, but there is one very, very large one on the high seas, which is in the Antarctic and the Southern Ocean, and it's the largest protected area in the world by far. It's the second largest in terms of strongly protected. That claim goes to Papahanaumokuakea in the Northwest Hawaiian Islands, which is the marine monument that President Bush first created and President Obama expanded. So marine reserves is another example where there's very powerful science. We have new partnerships with communities, with nations, new technology and new political leadership, and changing social norms around the awareness of this and the willingness of presidents in some cases to compete for mine is bigger than yours kind of thing, resulting in over an order of magnitude increase in strongly protected areas globally. Good progress, not as much as needed. They may be especially important as a new tool in the toolbox in enhancing the resilience of oceans to climate changes. The problem is that active resistance from extractive users and pretty much a complete lack of awareness by the public is really impeding progress. So looking across these three different types of problems and solutions, there's some common themes that are emerging. Some of those include the fact that science and evidence has really played a key role in each of these. It hasn't changed everything, but it has fed into and really informed the thinking about the choices and the opportunities. Stakeholder engagement, stakeholder leadership has been absolutely essential. Awareness by the public of the problems has been useful. National leadership has really made a huge difference in this arena. And finally, incentives, changing the incentives for the actors to do something has made a huge difference. And those incentives might be economic incentives, such as they were for fishermen with rights-based approaches, making it economically, aligning short-term and long-term incentives, which is what the rights-based programs do. But some of the incentives are social incentives, changing social norms or personal values. And both of those can trigger changes in behavior that we've seen. So an important emerging theme is that the right incentives can convert a vicious cycle of unsustainable practices to a virtuous cycle of sustainable practices. And again, those can be economic or social incentives. So we've talked about where I'm coming from in all this, why you should care about the ocean, what are the problems, what are some of the solutions. And I want to pivot now to all of you, because one of the biggest problems is lack of awareness of both the problems and the solutions, but also a lack of hope and a lack of a feeling of personal responsibility. And I'm reminded of the social scientist Everett Rogers' model of the diffusion of innovation. He studied innovation of technology or a new idea and said, what does it take for a new thing to go viral, to reach critical mass? And he says they're early innovators, they're early adopters, and then there's an early majority, and then a late majority, and then these are the laggards down here. And the question is, how do you reach a point here where something takes on a life of its own, goes critical, and is self-sustaining? And I think where we are in ocean awareness is pretty much down here. We have a lot of good solutions, but we haven't really gone critical yet. And the question is, what is it going to take to get us to that point? So what can you do? Part of my reason for being here tonight is to give you some hope. There actually is hope. There are amazing things that are going on. Staying informed is critically important so that you can answer not only your questions, but others' questions. But reducing your own carbon, water, and plastic footprints makes an incredible difference. All of the plastic problem in the ocean, most of that is single-use plastics that are generated not only by us, but by people around the world. And more folks are becoming aware of that and beginning to do something about it. But what you do in terms of your water use, your carbon use, makes a huge difference for the ocean as well as the whole planet. Choosing sustainable seafood is really important. I use the app from the Monterey Bay Aquarium Seafood Watch program as a way to tell me what's sustainably caught or farmed. But eating lower on the food web is also important in addressing some of these global issues. But people working together can do a lot more than individuals. So joining forces or supporting organizations, voting is critically important. I need not tell everybody that, but it's something that is important. But communicating with your elected representatives and even running for office are the kinds of things that people are thinking more and more about doing. Actions on land matter as much as actions in or on the water. And this figure just really illustrates how connected all of us are through waterways. What we put into our waste streams, what we put into our water makes a huge difference. And as Senator Lugar told me once, he said, okay, now I get it. Every state is an ocean state. And I thought, yep, that's it. That's exactly right. So I'm here to tell you that there are a lot of reasons to be hopeful. We have science-based policy reforms that are ending overfishing in a number of countries. The EU looked at what the US has done and is trying to follow suit. They passed a reform of their common fishery policy that is doing a lot of the things that we did. We know we can rebuild stocks. The ocean is resilient if we give it a chance to recover. We have increasing recognition of the importance of getting the incentives right. So paying attention to those incentives that are going to trigger changes in behavior, whether it's behavior of the big seafood companies or behavior of seafood buyers. Serious attention to ending IUU is underway, and it's really amazing to see that transformation. We're also seeing a lot of big new protected areas, not enough, but the fact that they're happening and the fact that they're delivering such amazing bounty is very encouraging. And then the fact that there is so much potential to turn things around. There's economic potential, there's social potential, there's environmental potential for getting fisheries right. And that upside report that illustrates that is again very powerful. So quite simply, we have solutions. We know they work. They're not at the scale that we need. They're not at the magnitude to address the magnitude of the challenge. So we need to figure out how to accelerate and replicate them. And that takes greater awareness and greater action. So in the ocean, we have a wealth of new changes. We have new actions on the part of many of the key actors. I've shared with you some of my perspectives, what are the problems and solutions and what you can do. And I started at the beginning focusing on, can we use the ocean without using it up? And I would leave you with the thought that the task is very daunting. Ecological limits are real, but example after example after example are telling us it is possible. So yes, I believe we can use the ocean without using it up. You have a key role to play. My hope is that we can recover the bounty and use it wisely. And so with thanks to my graduate students that have helped do some of this work, I would say to you, it's time for us to seize the day and chart a new course to use the ocean without using it up. It's time for a quantum leap in awareness and action. And my question to you is, will you help? Thanks.
Dr. Lubchenco will entertain some questions.
Thank you all for putting up with my coughing. Let's just alternate sides. Please go ahead, introduce yourself and holler out.
My name is Glenn. I actually have a degree in oceanography. But would you comment on seafood farms and tell us what percentage of our harvest comes from them now and what's projected in the future?
Yeah, aquaculture is a very key part of the solution to food security. It is a lot cheaper in terms of greenhouse gas emissions, water use, everything to grow food in the ocean than food on the land. The challenge is to do it in a way that is sustainable. And there are rich experiences that have been learned about that. It's not going to, and I don't believe should, replace wild capture fisheries. I think a combination of both of those is going to be the solution for a lot of the seafood for the future. There are a lot of different types of aquaculture. There are over 700 different species that are farmed in one way or another. And the challenges to aquaculture are quite variable depending on what it is. If it's farming algae, that's a lot easier. If it's farming filter feeders like mussels, oysters, clams, they're just feeding from the water, so you don't have to feed them anything. The toughest ones to get sustainable are the carnivores. So salmon, for example, or other top predators. And the problem with those is that to have that be sustainable, you have to think about what you're feeding them. And if it's mostly wild-caught fish that are the small pelagics that have been turned into fish meal, then that's actually contributing to depletion of the ocean, not replenishing the ocean. So figuring out how to have aquaculture be sustainable is an ongoing challenge, lots of new innovations in that space, and I think it will be absolutely essential part of our future. And you can help make that happen by paying attention to the seafood that you eat, and if it's sustainably caught or farmed, then go for it. Yes, David.
Yes, well, he actually took one of my questions, because in 2005, I remember at AAAS in Boston, you led a panel on sustainable aquaculture, which at the time was just east of an oxymoron. And clearly that's an example of something that's grown into a solution. To grow the solutions faster than the problems obviously takes a lot more political will, which is why on June 9th, Saturday, June 9th, World Oceans Day weekend, we're going to have the first ever March for the Ocean here in Washington, D.C. and around the world. And that's a very exciting moment that I just encourage people to go to marchfortheocean.org to learn more about. And since the agriculture question has gone away, let me go from my statement to another question, which is, how do you engage people on ocean acidification? How do you make people even conscious that this is a major problem in the world?
Thanks, David. And yes, I would encourage everybody, March for the Ocean, absolutely. Ocean acidification is a challenge. The ocean is now about 30% more acidic than it was at the beginning of the Industrial Revolution. Because the ocean is absorbing that carbon dioxide, there are chemical changes in the ocean that make it more acidic, and that makes it hard for anything that has shell or skeleton made of calcium carbonate. So everything from coral reefs to clams to crabs are affected. It's more difficult for most of them to make their hard parts, and their hard parts erode more quickly. So it's a big challenge, and it's going to get more challenging. The global pattern of increased acidity in the ocean is exacerbated by runoff from the land of nutrients. And so while we are working hard to reduce carbon emissions, we can buy time and lessen the overall problem along coastal margins by reducing the runoff of nutrients, both carbon and nitrogen, to the ocean. We're also learning that seagrass beds and kelp forests can help ameliorate ocean acidification locally. So this is an area where there's a lot of new science that's coming to the fore that I think will be instrumental in helping us make smart decisions, but it underscores the importance of reducing emissions. Yes, please.
Hi. Thank you. Can you tell us where we are, what we really know about methane release, perhaps under the Siberian shelf, and also what is that circulation or the hot and the cold? I mean, these two big, potentially really, changing this planet.
Yep.
Yeah, could you let me know what's actually going on that we might know, or what website to go to?
Both of those issues deal with what are some of the. They both deal with climate change. I think what you're talking about is the methane that is sequestered currently in, for example, many of the frozen areas of the far north. And as those are warming up, there is very real concern that the methane that it's in them will be released into the atmosphere. And methane is a very potent greenhouse gas. And so there are very real concerns that might make climate change even worse. We don't know how likely that is. It's certainly a possibility. It underscores the importance of getting on with meeting the Paris targets and actually doing better than the Paris targets, because there are uncertainties in the system. Pivoting to the ocean circulation that you're talking about, there is the movement of water from the surface to the deep sea and back. And that is driven by differences in the temperature and the salinity of water. And there is a key part of that circulation happens in the mid-Atlantic. And this overturning of the water masses has been measured. And very recently, people have determined that, in fact, it's slowing down. And that slowing down could have very real consequences for the global distribution of heat on the planet. We know that has happened sometimes in the past and has completely changed the climate when that has happened. So we know that it's possible. This again is one of the areas that has a high degree of uncertainty because we just don't understand exactly what it's going to take to trigger the kind of changes that we fear might happen. So it is possible. The most recent IPCC, the Intergovernmental Panel on Climate Change reports suggested it was possible, but as far as people know, it's not likely to happen in the near-term future. It's probably, if it does happen, it probably will be down the road. The recent information that it is slowing down is still being evaluated to understand exactly what that means.
Thank you.
Yes, thanks. Yes.
This is the news about the Great Barrier Reef of Australia. Recently was a news item in the New York Times about the size of it, which has been reduced to almost 50% of what it was before. And I'm just asking, what's your hope of a complete restoration of this with the effort being done?
What's happening in the Great Barrier Reef in terms of the bleaching is really, really tragic. This is, some of the most spectacular reefs in the world. And it is really discouraging to everybody who loves coral reefs and believes that those are important habitats to see that happening. What's of most concern to scientists when corals are stressed, in this case most likely by warmer waters, then they bleach, and the symbiotic algae that are inside the corals that give them their color are released. In some cases, corals can reacquire those algae. In some cases, they are actually dead and can't recover. And that appears to be the case with much of the areas that have now bleached on the Great Barrier Reef. The prognosis is highly uncertain. We know that corals historically have bleached, probably not at the magnitude that's happening now on the Great Barrier Reef, as far as we know, at least not in recorded time. And the real challenge to those reefs is that if there is bleaching, eventually they can recover. You can have new young corals settle. The corals that are there that might not be very abundant can spread. But the challenge now is that the frequency of these warming events is coming faster and faster, and it's coming faster than reefs have time to recover. So that's the real challenge now. I have been to other reefs that are highly diverse in the Indo-Pacific that are really, really remote. In the Philippines, for example, in the middle of the Sulu Sea, Tubataha National Park, where the same warming that triggered these massive bleaching in Australia and the Great Barrier Reef has not triggered comparable bleaching in these reefs that I've seen in the Philippines. And that area that we were diving in is a national park that has been completely protected. It's a marine protected area and has been since the mid-'80s. So it is completely protected. It has the full level of top predators. We have 12 different shark species that are there, great big huge tiger sharks, lots of other just amazing, gorgeous, beautiful creatures. But the reefs are super, super healthy. Because they're remote, they don't have any runoff from the land like the Great Barrier Reef does. It has silt, it has a lot of coal dust, it has salinity, that is fresh water that's coming from the land. The Great Barrier Reef, despite the efforts to protect significant fractions of it, has been stressed by a lot of other stressors. Overfishing, runoff from the land, And so one line of thinking is that it may have been more susceptible to bleaching because it has all these stressors, whereas Tubataha, which has none of those other stressors, was better able to withstand the bleaching. So there's some new interesting hypotheses that are coming to the fore. The final thing I would say about the Great Barrier Reef is that scientists are now discovering that there's a lot of genetic diversity in both the corals and their symbiotic algae with respect to tolerance of high temperatures. And there are certain genotypes of corals and zooxanthellae that are routinely experiencing high temperatures that don't bleach. And there's active investigation going on now. This is really a hotbed of research to understand and protect those, with perhaps the idea that some might be more thermally tolerant and we could plant them, outplant them, and they could be the source of reefs in the future. This is yet another reason why we need to be reducing carbon emissions as fast as possible, because these kinds of disasters are likely to get more serious before they get better. And so there's real urgency in getting on with this. I'll try to make shorter answers. We've got a lot of people asking questions, but they're great questions.
In elementary school, I learned about the abundance of the Grand Banks. So what is the prognosis for cod near Cape Cod?
Grand Banks were one of these amazingly productive places where, according to the ancient logbooks of fishermen and mariners and others, the cod would almost jump into your boat when you would go out to fish. They were massively overfished. And as you know, cod has plummeted in that part of the Atlantic. It has not recovered well. Other species that were overfished have recovered, but not cod. And the thinking is that there have been some shifts in that ecosystem, and that the young cod might now be eaten by other species that are in the system. And simply put, the habitats for young cod to recruit into are much less abundant than they used to be. There are a couple of havens where there are cod present. Cash's Ledge, for example, is one of them. Another one that was declared the first marine national monument in the Atlantic. It's called the Northeast Canyon and Seamount Marine National Monument. Those are safe havens for the few cod that are there. But I think the jury is still out on whether cod can recover, and it may be one of those species that just doesn't. So I made the point that the oceans are resilient. They're not infinitely resilient, and it means it's important that we protect as much as we can before we lose even more. Yes?
I'm Dr. Sam Hancock of Emerald Planet TV, and thank you for being here. But you have a great audience here tonight. You know, many people that will hear your presentation far beyond this. What would be, say, the 3 or 4 top things that you would say that we can do, that we can have a real positive impact and would be solutions, but something that really is doable, you know, from people just like us in this room and are very interested in what you're doing?
I think becoming aware and paying attention, being informed, finding good sources of information and supporting organizations you can trust who are active in these areas is very important. How you live your daily life is important. If you can reduce your carbon and water and plastic footprints, that has a huge impact when we add it up for all the people that are doing the same thing. Support elected officials who are concerned about these issues and tell them it's important to you and help them do what you would like them to do. Thank you.
Thank you.
Thank you so much for your presentation. It was very inspiring. My question is about the marine protected reserves, specifically the one in Antarctica, and I was really excited to see that. with regards to certain species that international law is deemed to be protected, but some countries continue to fish and hunt, such as the whales in Antarctica. When we want to respect other cultures, and when folks say this is our culture, how do we address that through diplomacy? Another example could be shark fin soup demand in East Asia.
Thanks for identifying that. Cultural practices do vary considerably around the world. The International Whaling Commission that was set up to deal with the issue of commercial whaling came to an agreement that it would respect the cultural values that certain cultures place in hunting for whales. We do that here in the United States. The Inuit in Alaska that hunt for bowhead whale, or the macaw who hunt for gray whales on the West Coast in Washington are two examples. And the agreement within the International Whaling Commission is that that is respected internationally and that is allowed. What is not allowed is commercial whaling for fish as opposed to indigenous whaling. And 3 countries have chosen to go against that and fish commercially for whales, Iceland, Norway, and Japan. And they have, there was an international court case a number of years ago where New Zealand and Australia took Japan to court internationally with the idea of saying, you are not abiding by the agreements of the International Whaling Commission. Japan lost that because what they said they were doing was fishing for scientific purposes, and it was clear that what they were doing didn't meet the criteria for that. So that is still an ongoing issue. And I think the international agreement to recognize that there are legitimate cultural differences is what the international community has done. People may agree or disagree with that. But the challenge has been that agreement has no real teeth, and countries are still doing what they want. So it's a very complicated issue. Final question.
Okay, I sort of have a two-parter, and they're not really related, so I suppose you got to call it 2 questions. So anyway, two things. So what advice would you give a young person who's looking to establish a career in marine sciences? And I said it was unrelated. In Florida, they're looking at creating a Goliath grouper fishery for sportsmen, I think harvesting that protected species. I'm curious what you think about that.
Okay. Advice to young marine scientists wannabes, go for it. It's an amazing, wonderful opportunity, and we need more and more young people with passion and ideas and good scientific training. But I think the training for the scientists of the future is going to be different from the scientists of my generation. It's more and more important for scientists to not only become experts in an area about which they're passionate, but also be able to work in teams, to understand economics and politics, to become better communicators. And so many of the young people that I see at Oregon State University are really branching out and seeing a wide variety of different potential careers for themselves, but needing to have a broader set of tools at their disposal than was the case when I was young. Goliath groupers are one of the most amazing fish on this planet. They are so cool, and they play a really important role in their communities, in their ecosystems. I believe that we should be not fishing Goliath groupers and have seen in places, for example, in Cuba, when the Cuban Revolution happened and all the foreign fishing fleets were kicked out. The fishermen in Cuba were sufficiently poor that they didn't have enough gasoline to do anything other than just fish along the southern, in this case, the southern margins of Cuba. And across the waters, but still in Cuban waters, there's an amazing place called Garden of the Queens that has been a de facto protected area because the foreigners couldn't fish there and the locals couldn't get there. So it's been a de facto protected area since the revolution. And as a result, there are just great big, huge, massive groupers there, Goliath and others. And the reefs are very, very healthy because these fish are playing an important role in those ecosystems. There is some catch and release fishing that's allowed there, but it's not for grouper. It's bone, tarpon, and permit, I think. And that, I think, is a really, if for anybody to dive in that place, you can see, so it's kind of going back in time and hopefully going into the future, because if we have big protected areas like that, then we can have havens for these really important iconic species that are so critical to the health of an ecosystem. And then that bounty can spill over to adjacent areas that then we can use. We can fish commercially and recreationally. So I think we need some combination of both. You all have been amazingly patient, fantastic questions, really engaged, and I am so grateful. Thank you so much, and let's work together. Thank you.
So I want to just remind everybody, in May, we'll have 2 Capital Evening lectures. One is by our new director of our geosciences, Dr. Mike Walter. The second one, that one is on May 9th, and the second one is on May 23rd by Ray Rothrock. He's going to talk about the cyberspace safety. I hope to see you back then.